Okay, so we'll be talking about APIs. Like I said, API is application programming interface. So, and when we say application programming interface, what exactly do we mean, right? So, like I said, human beings are the ones that operate software, but as advancement began, innovations began, then later softwares now started to talk to softwares. So think of it as think of your typical e-commerce. So in your typical e-commerce, a human being will start the process, would probably go to Amazon.com, and then he's going to order something. Now, when you go to Amazon.com, oh, you're not seeing my screen yet. All right, let me share what I'm looking at. Screen two. All right, can you see my screen? Can anyone see my screen?
Yeah.
Okay. So when I go to Amazon.com, and yesterday I was trying to get an ergonomic chair, and then I picked up a chair and I say I want to buy this chair. Now I've looked at this chair. So number one, let me tell you a lot of things about this thing. This image, right, is coming from somewhere else. This image is not necessarily in this application that I'm using to make the order. So this image is somewhere else. So we have to go retrieve this. I mean, the software had to retrieve this image from somewhere. You see how clean it is. So, and then all these images are kept in a different place. This Amazon software had to go load these images. That's software talking to software. So by the time I select this and I say I want to add to cart, I want to buy, and then I get to the point of, make purchase, I'm going to probably use my card. By the time I'm entering my card details, that this software will then talk to another software somewhere else to validate that my card is correct, to validate that my what's it called? My card is correct. I have enough balance to make this kind of purchase. And then when he validates that and I agree to purchase, another software will talk to another software and say, take this amount of money from this guy's account, put it in another account, and tell this guy that this is his new balance. So that is software. So human being started the interaction, but softwares have taken over. And then like 5, 6, 7 layers of different software have spoken to each other. And then before I finally gets that your order is successful, your payment is successful. Are we together? So that is typically what APIs does. API is the intermediary, is how software talk to software. That's a simple term. That's a simple way to define it. I mean, you can say a lot of complex definitions, but that is the heart of it. Communication between systems, and there is no human intervention. Great. So I just showed us this so that you can think along with me in terms of APIs. So Amazon has APIs for payment, APIs for loading images called CDN, Content Delivery Network, APIs for a lot of things. And it's all these APIs that comes together in one single application, and then user can interact with that single application, and this single application is calling all the different APIs in the background, and that's what forms this Amazon store. See all the different types of products, everything has API. Add to cart is an API, buy now is an API, everything is an API, every single functionality. Wish list has its own API. Yes, so I don't work with Amazon, but I know very well that this is the way this was built, because that's the only way it can be scalable. So I'll show you something more. So when we say APIs, we're talking about communications, and I just quickly built this while we were discussing while I was preparing. So this is typical. It's just a website where you can create sequence diagram. Now I know all these things are new to you. Sequence diagram. This is it. So as I'm giving those terms, just if you have a biro and a paper, just write them on your notepad. Just put them somewhere so that you can do more research in future if you have to. So sequence diagram is like a step-by-step flow of the process, how it starts, where it goes, how it ends, and how it terminates, those kind of things. So look at this. This is typically what you want to do. So picture yourself as building an API for that to-do list. Now, you guys will enter a lot of frustration when you had your to-do list, because the moment you stop the application, everything you've added will disappear, right? Did anybody experience that?
Yes.
And you're like, I made a mistake. So for you to be able to do it again, you have to add new sets of to-do lists and then test it out. And by the time you stop and make a correction, it's all gone. So, and I was telling Pascal that that's where the idea of databases comes in. So the data that you've generated now, you now store it somewhere and you persist it. It's called persistence. Persistence means that this data can be available any other time that I need it, aside that just the time I was running that software. So typically, your to-do, so what we're going to do is to build an API for that to-do application. And instead of, your to-do list disappearing every time you run your application, then you can keep your to-do list somewhere in a database, and then you can retrieve it, you can edit it, you can update it, and all those kind of things. So there's something called CRUD, C-R-U-D. CRUD is a database term. It means create, read, update, and delete. CRUD, CRUD. So when they say perform CRUD operations, it means perform a create, perform a read, perform an update, and perform a delete. Those are the 4 major things you'll be doing with data. So let me go back to my Amazon site. When I had something to my cart, if it wasn't there before and I had it to my cart, then I've added. So if there was a database that is holding my cart, now my cart has 1, 2, 3 items. So typically I might just say that, okay, this is not supposed to be my cart, so I'm deleting this. When I delete this, it takes it out of the cart. When I had, so that addition is the adding, deleting is the deleting. When I update, maybe my quantity was 1 before, now I say I want to buy 2. That is an update. And then when I delete, You know what delete means. So does that make sense from the beginning up until now to everybody?
Yes, yes.
Han, I can't hear you. Han, why are you permanently on mute? Everybody should on mute except there is so much noise in your background, so that you can speak and I can also hear you. All right, so I'm just trying to confirm that we're all on the same page. This CRUD makes sense. Create, read is to fetch or to retrieve. Then update is to update something. Delete is to delete. Great, so this is typically what we're going to probably do. And this is our API. There's going to be a caller. Now, every time you're building an API, there has to be somebody that we call that API. Whether it's calling it to do a create or to do a delete or to do an update, whatever it is, there has to be a caller. And typically, there's also going to be something called a database where you're probably going to store data. So look at my sequence diagram. Can we all see this diagram very clearly?
Yeah, I can see it.
Okay, so there's a caller. The caller is trying to get all your to-do lists, which is what you are doing. You remember in your code where you are trying to create a list and then put everything inside. So when the caller calls your API will go to the database and fetch everything, and then return all the item back to the API, and the API returns everything back to the caller. Does that make sense to everybody?
Yeah, it does.
Okay. That's the read operation. That's read. Then adding a to-do list, that's create. So your caller will send you a to-do list and say, I just want to add this to-do list. Your API will receive it and send that to-do list to the database. The database will accept it and insert that record. Once the database accepts and insert that record, a database will send back to the API, then the API will respond and says that I have successfully, created this to-do list, and respond back to the caller. So those are two simple flows for read and create. So I'll do another one for delete, and then I'll do another one for update. I hope we are all together. Yes. So when we talk about all this flow, so how does all this flow happens? How does all this flow happen? There's a background noise. That person can mute. I just want, if you don't have like any background noise, then you can unmute. So like I was saying, and then you look at this. So you ask yourself, how does all this thing happen? How would they even happen? So in the web protocol, there's something called HTTP. I'm sure you guys have had HTTP a lot of times. HTTP. Now, you don't know, let me assume you don't know so much about computers, but there is something called HTTP. Is a protocol. It's a protocol used by look at this definition, by www. www is like the internet, and then we'll talk about browsers, we'll talk about web servers, So browser, so look at my typical computer. When I say google.com, you know what I'm doing? I'm sending a get. I'm telling the internet to get me a file called google.com. When I press enter, this is the file that came back. This file has been understood by my browser. So I want you to get this. This is a file. Google.com is a file. That file has been understood by my browser. And then my browser now rendered the content of that file. Every other website is also a file. So www.linkedin.com is a file, is an HTML file that the browser has also understood and rendered. You understand? So think of this. I mean, you get to understand this more better in future when we do HTML, when we do CSS, when we do web browsers, when we do IIS and Web 7 and all that. So, but I wanted you to get this context of what I'm trying to explain. That you will send, when you're sending all these messages, you are sending, when you're calling your API will be on the internet, or it will be on HTTP protocol. But when you're sending to database, the database will use another protocol entirely. So let's focus from here. Let's focus from our caller to our API. So you send a get, you send a create, remember your CRUD. So does anyone have any question around everything I've explained? No questions?
No.
Okay,
No, I don't
great.
know.
Great. I'm happy you guys understand that. So that is what we're going to be doing, in this week. And then we're going to be building a web API. And that web API will be used to, manage all your to-do list. If we can't get to it this week, we will do, maybe if we can't, by next week, we'll now create a database where we're going to be storing, the to-do lists, and then the APIs will be retrieving them. And then we can now build something that will now call the API. So that way, your data will be stored persistently. And then the other good thing about APIs is that you can now connect a lot of things to your API. So for example, you can build an application on a smartwatch for your to-do list. You can build a mobile app for your to-do list. You can build a Android, iOS, web app, console app, anything can now interact with your to-do list once you make your to-do list an API. So, and that's the way technology comes together. So so API is something that is paramount. You must know it, you must understand it, you must be able to build it, you must be able to design it, you must be able to play around it, and you just need to get it because it's the heart of what you'll be doing in software development. 20 years ago, if you were learning software development, you don't need to know anything about it. There's even nothing called APIs at that. But right now, this is the heart of what we do. So when I say I'm working, I work as a software developer. What do? I'm building APIs. I'm telling you, that's my job. So if someone say if you're not a front end designer, you are building API, because there's nothing else you'll be building, right? Because API is now the way, or the front end we talk to the back end, right? So an API is back end. So I started this journey for you from the back, so that you walk from the back and then go back to the front. Some people will start from the front and tell you to go back to the back. I mean, it depends on style, but I found this to be more effective when I start from the back, and then you understand everything in the back, and then we now go, and then we go to the front. So the front end is what you are seeing on the screen, which is the Amazon.com, all the pictures and all the frame and everything. So that's the idea. That's the idea of being able to do something with those things. Yeah, so that's the background I'm going to lay. And I hope everybody's clear on that. Like I said, I have an appointment for 10 o'clock. So I'm driving my baby for immunization. So it's not too far. So I just thought, let me start earlier so that we can use that as a break, and then we can come back because I have another meeting for like 12 o'clock. Okay, so that's so when you say API, so let me now tell you a number of things that I need you to understand. So in HTTP, in the world of HTTP is the protocol that we use for communication on the web. So, and your APIs will be using that as well. Can you see my screen? Can you see the standard port for HTTP is what?
80.
80. So
80.
HTTP runs on port 80. Now, there is a senior brother of HTTP called HTTPS. Now, if you've never heard of, you must have heard about HTTPS. It's just the secured form of HTTP. Now, he runs on port 443. It doesn't run on 80. It runs on port 443. And the difference between them is that HTTPS has a secured layer on top of it. So every communication passing through HTTPS is encrypted, such that you cannot see them in plain text. So that's the difference. Now, when I ask you what port the HTTPS runs on, is port 443. What port the HTTP runs on, it's port 80. There are other protocols that you should also take note, that you will need as an IT person. There's a protocol called FTP, File Transfer Protocol. It's not HTTP. HTTP is markup. HTTP has can do images. That's why the web is progressing, because we can do images, we can do picture, we can do multimedia. But there's another protocol called FTP. We can only do file. You can read more about them. It's different from HTTP, but it's also a protocol like HTTP. So, and then we use that to do something else entirely. We use it to transfer file. There's something called SFTP, secured FTP, right? That's also for file transmission, but it's also more secure. So, and then within the HTTP, there are a number of things. I mean, I think you should read this article from Mozilla. I'm going to send it to the Slack channel. Read this article from Mozilla. So yeah, and then this article would help me a lot. Yeah, so HTTP is a protocol which allows the fetching of resources such as HTML documents. It is the foundation of any data exchange on the web, and it's a client-server protocol, which means requests are initiated by the recipient, usually the web browser, a complete document is reconstructed from the different subdocuments fetched. So like I told you, google.com is a file, is an HTML file, and that file is made up of, different things, text, images, everything. Now, when you do google.com on the internet, it goes through your request. This is your browser. You send a request, it sends a get. Get means to retrieve. A get is a method on HTTP, and I'll soon get there. So this goes to the internet, goes to your web server. Web server is where you are holding that file. Is where your application is. It's where your software is hosted. And then retrieves that document and then return it back to the web browser. And the web browser has the intelligence to interpret that document and render it correctly. And that document is made up of HTML, CSS, JavaScript, web APIs. And this is where we are. If you can see my screen, I'm mousing over web APIs, right? This is like the back, and then from the front is the visual, which is HTML. And the whole protocol that does all the work is HTTP, right? And there's something called DNS, domain naming system, and there's something called IP address, and there's something called TLS, and then that all now makes up what the web is. Don't worry, I'll explain everything. 10 o'clock now. I'll explain everything and I'll try to break them down so that you understand. So these are things you will know in your sleep, even if they wake me up in the sleep and they say, what is client? What is server? What is TLS? What is UDP? What is TCP? What is HTTPS? I can say everything offhand. I don't need anything I don't need to reference anything. And that's what will happen to you as well. So, but gradually you will understand them. Now, HTTP is an extensible protocol over time. It's sent over TCP. I like you to read a couple of things there because I can't explain everything right now because of time. TCP is Transmission Control Protocol. It's a reliable form of communication. Reliable transport means that when I send a request, I will wait for a response. There are some other systems that when you send a request, you're not waiting for a response. You just keep sending. Like when you're having a phone call with somebody, when you speak, you're not waiting for them to speak back before you speak again. You know that they hear you, so you just keep speaking. And the other person too keeps speaking. Are we together?
Yeah.
Hope I'm not too fast.
No, you're not fast. It's okay. I'm following up.
Digest. So I need you to digest this that I'm saying. So I've told you about web server where you are hosting your application. I've told you there is internet, which HTTP protocol runs on, and then HTTP protocol helps you to get things from a web server, pass it back to the browser. The browser can interpret and understand everything. Yeah, that's it. So what are the components of an HTTP-based system? HTTP is a client-server protocol. Client-server protocol means that somebody sent a request, and then somebody gets a response, and then somebody responds. So that's request-response system. So the client is the person making the request. The server is the person responding. So I make a request, and then I get a response. I make a request, and then I get a response. And that's the way we do everything on the internet. When you click on add to cart, you are making a request. When the item gets added to your cart, you just got a response. And that's the way it is. So a lot of things happen in between. A lot of things there can be proxy. Proxy is like an intermediary. You must have had proxy server. For those of you that work in enterprise, you must have heard of proxy server. Ben, you should know proxy server now, or you've not had proxy.
I know what it is.
Oh, great. So, those kind of things. So proxy is like an intermediary, between your client and your server. And sometimes you can have multiple proxies along the way, even on the internet. So client is the user agent that acts on behalf of the user. So a lot of times your clients can be like.
Could be an example. Okay.
Of a client?
No, proxy.
Of a proxy. A proxy is like so if you work in, yeah, you also worked in an enterprise. So the way enterprises are built, what they do is they don't allow your request to go directly to the internet, right? So even if you enter like your office and you open your browser and you type google.com and you search the internet, your traffic is not going straight to the internet, it's going through your office proxy. So, and the reason they do that,
like an intranet.
exactly, yeah, not like intranet per se. You know, even within your intranet, you know, you can browse the internet, right?
Yeah.
I mean, you can, except they block it in some cases. So, but I'm saying that every time you are in you are in somebody's private network, like your office network, and you are using the internet, it's going through a proxy. That's why they can monitor everything you are doing. That's why they can know the people that went to view pornographic sites. That's why they can know the people that went to this particular site that they've told people not to go. So how would they know? The reason they know is they pass everybody through a proxy. So on that proxy, you can now add another layer of security. You can now scan the people that are doing Naira bets in the office. You know, you can. So that's an example of a proxy.
Okay. So is it like a filter?
Yes. So you can.
Like it keeps records.
It's like a pipe. It's not a filter per se, but you can now put a filter on top of it, right? So it's like a pipe. You are passing every request to go through this pipe. That's your proxy. So you can now put at the end of that pipe and say, I want to block anybody going to YouTube. I want to block anybody going to NairaBet. Do you get?
Okay.
So I can block all the requests. I can and let the request that I want go through, and stop the other requests that I don't want.
Okay.
You understand? So that's the idea, right? So
let me just ask something. Like for example, now Netflix, yeah. Like the controls on Netflix, does that work as a proxy too or not? No.
Controls on Netflix.
Like the guidance thing, you could set a particular profile to be kids or adults to screen the content probably.
Yeah, so technically it's a proxy. I mean, in terms of what it's doing. So, but what they've done is instead of putting that filter at the back end, they now made that control available to you. Do you understand? So you are typically controlling what's going on behind the scenes.
Yeah.
You know, and that's what technology can do. So on a normal day, you are not supposed to have control over that. They have the control. So they've now said, okay, let's give you that power. And you know, because of that, everybody is very comfortable using Netflix. You just go to kids, and then all the adult content are filtered out.
Yeah.
Yep. So that's technically like that's correct, and I like that. You know, that's comparison. All right. So if you read this client user agent, you see what the browser is trying to do. There's something called HTML. There's something called CSS, and you know they come together to form what you see in the browser, right? CSS is what brings all the colors and all the layout and all the arrangement. HTML is what brings all the text. And then, you know, you can put in, look, if you look at this website, for example, this is an image, this is text, and then this thing is properly aligned. So it's CSS that helps us to align it. Is CSS that helps us to arrange it. Is HTML that give us the text and the images and the outline. It's CSS that give us the colors. So, and then everything comes together. Your request then goes to what they call a web server. The web server is where you are hosting your application or your API or your system. That's where your request goes to. When your request get there, the web server knows where to send your request. So for instance, you can have 100 applications on one server. When you send your request, your web server will look at, okay, this request that is coming, which application is it supposed to go to? So your web server will, so for instance, now Amazon.com, then there is developer.amazon.com, then there is information.amazon.com, and all of them are on the same web server. So when I hit developer.amazon.com, the web server looks at it and say, okay, this is a developer site request, and then sends it to the developer. This is a normal request for shopping. Sends me to that shopping. Do you understand? And as it's sending me to each of these shopping or whatever, wherever it's sending me, those people, they understand that request and they can respond. They can give me back what exactly I want. So read this page. I'll be out shortly in a few minutes. Read this entire page. I mean, read it from the beginning and try and make sense of it. When I come back, we would, discuss further, and then we'll start on how can we even develop this API. So there's also a tool I want you to install. The name is called Postman. Postman. So those are the things I want you to do before I come back. Postman, I just wrote the name on, but let me even give you the URL. So I want you to install that on your system so that when I come back, you're not just trying to install it, and then we can play with some stuff. Postman.com. All right, I just sent you postman.com. Right, so please read everything on this page as much as you can and as much as you understand, and then try and find the difference between a post and a get. Difference between, I want everybody to write them out. Difference between a post and a get. At least one person will give me one difference. Post and get. What's that? Okay, I thought someone was saying something. Right? So let me give you one example. One example. So when I'm retrieving something, I use get. But when I'm sending data, I use post. Are you guys with me?
Yeah. When
we're retrieving things, we use get. When we are sending things, we use post. So when I say this, then when you are studying the difference between them, then you will understand the reason why, we use get to retrieve and the reason why we use post to send. So this is, if you understand HTTP, APIs and the whole interaction that happens, see, you've understood the heart of software development, because that is the center. It's all about sending requests and getting response. Whether you are building a shopping cart, whether you are building a online e-commerce, anything you are building, whether you work for a bank or you work for a telecommunication company, everything is about somebody sending a request and then somebody expecting a response, and then you are doing something with it. So I built an API, over a platform called SendGrid to send email in my company. And it's all about me. So I get all the email they want to send. I push them together in my software, and then I call the email API that will help me to send it, right? And then I send the old data to them in a secured way. And they take in all my requests and then pass it to send all the emails to all the users, because we want to send a lot of emails. And if you don't go through a email data provider, you might be blocked for spamming people. I mean, I'm just trying to explain to you that every single thing you do, as far as being a software engineer is concerned, will revolve around this. If you're a front-end designer, you will be designing something that the browser will show. If you're a back-end designer, you'll be taking something from the front end, taking it to the back, passing it to a cache, to database through the proxy, doing compression, doing caching, changing something in the cookies, and then doing redirect and everything. And that's what's on this page. So if anybody is learning development, I refer them here, because everything you need to know is here. And once you know this, every other thing is just on top of it. Right. So I'll be leaving shortly, like 9:50, and then I'll give us like 30 minutes thereabout to digest the things here. If you don't understand some things, no problem, just note them down. When I come back, I will explain whatever is it that you don't understand on this page. And I'll try and break them down as much as I can, right? Because I think this is where I started my IT journey from, understanding this. I did networking. So I studied TLS, I studied TCP, UDP. And then from there, so because I had understood networking and I know what it means to pass data through wire, you know that the data we pass goes through wire. For those of you that work with cable behind your network, you know that one cable behind your computer is always blinking. That cable that is blinking is actually